Myself, Rajesh Nava, instructor from Civil Department, PGMNT Engineering College, Indore. Today we are conducting the experiment of rectangular notch. Here we have to determine the coefficient of discharge for the triangular notch. In the observation, here the area of collecting tank, that is length into width. This is minus area of overflow pipe, because in the tank there is a pipe of 63 mm diameter pipe is there, so that we have to minus the area of that overflow pipe. L into B minus pi d square by 4. Next, this is the angle of notch, that is theta. This is the V notch. We have to measure this angle. It is called as also apex angle. It is called as apex angle. This is the crust level. This point is crust level. We have to measure the H value. Means here this is H1, crust level, and afterwards when you flow the water, it flows up to this level. Assume that this level will be water flow. That is called as H2. We have to minus capital H is equal to H2 minus H1. You will take the reading of H1 and H1, initial reading, and this is final reading. And this is angle. Here this is the notch, and we have to measure the angle of this notch like this. See that? This is the angle of the notch. This is 90-degree notch, and then on we have a 60-degree notch. This is the 60-degree notch. Now I am doing experiment with 60-degree notch. So the theta is 60 degree. The angle of this notch is 60 degree. For the theoretical discharge, this is the formula. Q theoretical is equal to 8 by 15 tan theta by 2. Theta is nothing but 60 degree. Okay. H is difference of H1 and H2. H raised to 5 by 2 square root of 2g. G is acceleration due to gravity. G is equal to acceleration due to gravity is 9.81 meter per second. This is the G value. Next, we have to calculate actual discharge. Actual discharge is nothing but volume by time. Volume is area of, this A is area of collecting tank. R is rise of water, and means how much we will collect the water. It is the rise of water. Next, divided by T, time taken to collect R centimeter of water. After getting Q actual and Q theoretical, we have to now we are finding the CD value, that is Q actual divided by Q theoretical. This is the observation and formula. Now we start the experiment. This is the setup of notch apparatus, and this is sum, and this is flow regulating valve, and this is flow channel. Here we provided a jellies to reduce the velocity of the water. And next, here is the pointer gauge to check the H1 and H2. Now This is the notch what we showed earlier. This is 60-degree notch we fitted to this channel. Next, this is the collecting tank. This is the collecting tank. We have to measure this collecting tank, outer side of this tank. Here, this is 20 centimeter. Okay, here is the 20 centimeter. It's 20 by 20 by 10. It's 40. 20 by 40. This is the 20 by 40 tank. And then I said you that here this is the overflow pipe in this tank. You have to deduct the area of this overflow pipe. This pipe have 6.3 centimeter. 6.3 centimeter pipe. This is. You have to deduct this area of this pipe. So because the water is collected in outer side of this pipe, and this is piezometer to check the water rise in the tank. Okay, first in the experiment you have to allow the flow in this tank by switch on in this motor. First allow the water and water starts flowing. Once water reaches up to this crest level, we have to switch off the motor and wait until the flow stops from this notch. We have to wait up till the water stops from the flow stops from this notch, because we have to take the crest level reading, that is H1. Now the water is completely stopped flowing from this notch. This is the we have to check the initial reading, that is H1. Just touch the water surfaces with the help of this pointer gauge. Okay, now this is touch now. This is 6 centimeter. 6 centimeter is the H1 reading. After that we have to set the flow now. Now adjust the flow and switch on the setting the flow. We have to wait for 3 to 4 minutes and we have to check the final reading with the help of this pointer. Now it is H2. At the water surface. 12.8 is the final value, that is H2. To calculate the power setting response, H1 and H2 is the reading. Now we have to take actual discharge. With the help of this butterfly valve, we have to close this butterfly valve. After closing this valve, the water starts collecting in the sewer. This is the water starts collecting in the tank. We have to check the, now I am checking 10 centimeter water rise. What is the time taken for 10 centimeter of water? Now I will start stopwatch at 7. Started. I will stop the stopwatch at 17. Stop. This is the time 7.09. Means 7.09 is the key value and R is 10 cm. This is the complete concept of reading. We have to repeat the same. We have to repeat the same procedure to take the second set reading. Afterwards, we have to calculate the after completing the experiment. This is the tabular column. This is pointer gauge reading what we have taken in initial reading. This is as given 6 cm. We have to convert it to meter, 0.06 meter. Next final reading it is 12.8 cm. It is converted to 0.0128 meter. Here head on water is equal to H2 minus H1. 0.128 minus 0.06 is 0.068. Next, this is theoretical result. Actual result, what we can price of water, it is 10 centimeter. So, divided by 100.1 meter. And time taken is 7.09. This is the calculation. First, we have to calculate the area. Area is equal to length to be and is equal to flow. It is 20 by 40, means 0.2 into 0.4 minus of pi d square. Pi into d means 63 mm. Means 0.063 square divided by 4. That is area is 0.0769 meter square. This is the area and theta is equal to 60 degree. Now for theoretical discharge, formula is 8 by 15 tan theta by 2 h raised to 5 by 2 square root of 2g. 8 by 15 is 8 by 15 tan theta means 60 degree tan 60 by 2 into h is 0.068 raised to 5 by 2 square root of 2 into g. G is acceleration due to gravity 9.81. So substituting this value, the answer is 1.64 into 10 raised to minus 3 meter cube per seconds. This is cube theoretical. You have to write it this in 1.664 into 10 raised to minus 3. This is the theoretical discharge. Next, actual discharge. Actual discharge is A into R over T. A is here 0.0769. R is 0.01. This is R 0.01 and time is 7.09 is the time. After calculating this, answer is 1.08 into 10 raised to minus 3 meter cube per second. Next, this is 1.08 into 10 raised to minus 3. This Q actual and we got Q theoretical. After substituting this Q actual divided by Q theoretical is Q actual 1.08 into 10 raised to minus 3. Next 1.64 into 10 raised to minus 3. The value is CD value is 0.66. This is 0.66. 0.66 is the CD value. You have to, this is the calculation part. For the next reading, you have to take this reading and calculate the same process. Hope you all understood the experiment.